Hi guys, this is the 2019 question 8, a statistics question. So a motoring magazine collected data on cars. Certain details on 800 cars were collected. The ages of 800 cars were recorded. 174 of them were new. Find the 95% confidence interval for the proportion of the new cars. Okay, so to write our 95% confidence interval, we are going to be looking for the population. So we're going to be estimating the population based on our data. So that will be the population proportion minus 1.96 times our standard error of a population proportion, which in our log tables is given as p hat times 1 minus p hat all over n. And then our population proportion plus our standard error, 1.96 times square root of p hat times 1 minus p hat over n. So if we want to write a 95% confident interval, we are estimating what is the population based on our sample proportion. So the first thing we have to do is find what our sample proportion is. So this is x over n, our desired over our total, that's 174 over 800, which gives us 0.2175. And from here, we're just going to substitute these values into our confidence interval. So this will give us 0.2175 minus 1.96 times the square root of 0.2175 times 1 minus 0.2175 all over n, which is 800. And then we do the exact same thing on the other side, except we have a positive sign. So 0.2175 plus 1.96 times the square root of 0.2175 times 1 minus 0.2175 all over 800. And multiplying this all out, this gives us a population between 0.18891 and 0.24608. I'm going to write this to 4 significant figures, so I want 4 figures that do not include a 0. So writing this as a percentage would give us 18.89% and 24.61%. So this means that based on our data that we've collected, we have created a test statistic for the population stating that the number of cars, or the proportion of cars that will be less than a year old, is between 18.89% and 24.61%, correct to 4 significant figures. In part 2, we're asked, the data on the speeds of these 800 vehicles is normally distributed with an average speed of 87.3 kilometers per hour and a standard deviation of 12 kilometers per hour. What proportion of cars on this stretch of road would you expect to find travelling at 95 kilometers per hour? So what proportion we're asked for, what is the probability of a car travelling above 95 kilometers per hour? So our data is normally distributed. Let's draw out our normal distribution curve, which will show us what we're looking for. Okay, so just writing down what we're told that the mean is 87.3. We're told that the standard deviation is 12. And we're told that we're looking for the data that falls above 95 kilometers per hour. So X is 95. And we're looking for the proportion or the area that falls above 95 kilometers per hour. So X is 95. Let's put that information on our normal distribution graph so we can see what we're looking for. So X is 95, and I want the proportion of cars that falls above 95. So I'm looking for this area here, I'm looking for the probability of x being greater than 95. Find our proportion or our probability or our area under the curve, we need to convert our data into z-scores. So we're going to use the z-score standardizing formula. Z equals x minus mu divided by our standard deviation. So z is equal to 95 minus 87.3 divided by 12. Z is equal to 0.6417. Now we find our z-score. We're looking for the area above a z-score of 0.6417. So we're looking for the probability when z is greater than 0.6417. So now we're going to use our log tables to convert this z-score into an area under the curve for that z-score. The problem is that in our log tables, the z-scores only tell us the area that falls below a certain z value. So the probability that z is greater than 0.6417 is the same as writing 1 minus the probability that z is less than 0.6417, rounding to 0.642. So we're going to use our log tables to find the area that's less than our z-score, and we know the total area under the curve is equal to 1, so we're going to take that value from 1, and we're left with the probability where z is greater than 0.642. So the area under 0.642 is equal to 0.7389. 1 minus this value gives us an area or a proportion of 0.2611. Written as a percentage, if you like, is 26.11%. So 26.11%. Okay, part 3 states that the driver of a car was told that 70% of all speeds recorded were higher than his speed. Find the speed at which this driver was recorded. So we're looking for x, the speed of the driver. With normal distribution questions, the first thing we do is draw out the information that we're given. So we are told that at a value greater than x, we have 70% of the population. So this shaded region is equal to 0.7, and we're looking for x. We're told in the previous question that mu, your mean, is 87.3, and we know the standard deviation is 12. So to find our value of x, we're going to use our z-score standardizing formula. This states that z is equal to x minus mu divided by our standard deviation. So I can find x if I know what is the z-score for this data point. We want the z-score that represents a population that is greater than 70%. So we want the z-score for this information right here. Now we know two things. The z-score is going to be a negative value because it will fall below the mean. We also know that our z-tables only tell us the value that is less than a certain z-score. So I need to find the probability where z is less than z1. This is equal to 0.53. We want this negative z-score, so this gives us a z-score of minus 0.53. So for a probability greater than 0.7, we have a z-score of minus 0.53. From here, we substitute our information into our formula and solve for x, our data. This gives us 12 times minus 0.53 equals x minus 87.3. Multiplying it out gives us minus 6.63 plus 87.3 equals x. which gives us x equals 80.94. And we're asked to give this answer correct to the nearest whole number, which gives us an x data point as 81 kilometers per hour. Okay, looking at B part 1, a road safety programme was carried out in the area using posters, signs and radio slots. After the programme, the motoring magazine recorded the speeds of 100 passing cars. The magazine carried out a hypothesis test at a 5% level of significance to determine whether the average speed had changed. The p-value of the test was 0.024. What can the magazine conclude based on the p-value? All right, well, the first thing here we need to remind ourselves is what the p-value actually means. So the p-value is the probability of collecting data that is more extreme than your test statistic. So what is the probability that data will fall outside your test statistic? If your p-value is less than 5%, we reject the null hypothesis. This is because if you have a p-value less than 5%, it means that your test statistic falls outside the accepted region of a z-score of 1.96. So it falls outside that 95% interval. A p-value of 0.024, which is less than 0.05, therefore our hypothesis is rejected. There is no change. The reason? A p-value of 0.024 is less than 0.05 and therefore our null hypothesis is rejected. Part 2, we're told that the magazine found that the average speed of this sample was lower than the previously established average speed of 87.3 kilometers per hour. Find the average speed of the cars in the sample correct to 1 decimal place. So let's write down what we know. We're looking for the sample average speed. So we're looking for the sample mean. We're told that the population mean still stands at 87.3. and our standard deviation is 12. We also know that our sample size is 100 cars. To find our sample mean, we need a formula for our sample mean. We're going to use the standardizing formula for a sample mean, which states that Z equals your sample mean minus your population mean divided by the standard deviation over the square root of our sample size. Here I'm just going to fill in what I know so I can work out what I need to find. So I don't know Z equals our sample mean, which I'm trying to find, minus 87.3 over 12 divided by the square root of 100. So we can see from this that in order to find our sample mean, we must have the equivalent z-score for that data point. To find our z-score from that data point, we are going to use the p-value, which is given in the previous question. All right, so let's draw up what we want and what we know. So we know that the p-value is 0.024. This is a two-tailed test, which means that our extreme values, so the areas at the end, are 0.012 on both sides. So the p-value is the probability that a point will fall outside of the data that you've collected. That's your extreme values on both sides, 0.12. So we want what is the z-score that will give us this probability or this area of 0.012. This is the same as saying the probability is equal to 0.012 for some z value that is less than, let's call it z1. You can see that this z-score is going to be a minus value. So instead, we find the probability for z is greater than the z1, equal to 0.012. To find the z-score, it is 1 minus the probability that z is less than this value. So it's 1 minus 0.012. So we want the z-score that gives us an area of 0.988. Going to our log tables, we find our closest z-score for 0.988 as 2.26. So we know that our sample speed was lower than previously established, which means that my z-score will be a minus value because it falls below our mean of 87.3. Therefore, our z-score is minus 2.26. Taking that data and substituting it into our formula gives us minus 2.26 equals x hat minus 87.3 divided by 12 over square root of 100, which gives us minus 2.26 equals x hat minus 87.3 over 1.2. Cross multiplying to find our sample mean gives us minus 2.26 times 1.2 equals x hat minus 87.3. Solving it out, we get 2 minus 2.712 equals x hat minus 87.3. Bringing the 87.3 to the other side gives us minus 2.712 plus 87.3 equals our sample mean, which gives us a sample mean of 84.588. And then rounding to one decimal place gives us a sample mean of 84.6.